right, if you didn't get a packet yet, make sure you have one.
How many people leave us? Oh, only one person. Imagine that.
Look, hey, the next couple days we're going to be spending on transforming linear functions. So I know that everyone in here has dealt with slope-intercept form before, and you've dealt with graphing lines. But it's important that you remember the format. And you guys are all going into Algebra 2, so you've been in geometry for a year, and we didn't go through that last year. So just a quick reminder, and I don't want to spend tons of time on this page, but a quick reminder, slope-intercept form is y equals mx plus b. Tell your neighbor what each of those variables mean. Okay, time's up. Hey, what does y or what does m mean? M is your slope. Another name for slope is? Someone said it over there. Some of you said a couple different things. Someone said y over x. It's almost y over x. It's actually change in y, so delta y over change in x, delta x. Also known as, someone else said it, rise over run. Okay.
Delta, everybody understand what this simple delta is about? In science, the science term representing change. The little triangle symbol there in a science concept represents change in something. So delta t would be change in time. Delta y is change in life.
Okay, what's B? Y-intercept. What? Tell your neighbor what the y-intercept is. Good. I heard somebody say where it crosses the y-axis. Okay, with your arm, show me the y-axis, please. Yeah, some of you are doing the z-axis, but the y-axis does this. The y-axis is like that. Okay? So recall that's your y-axis. This is your x-axis, and then later this year we'll actually add a new axis called the z-axis. Okay, we'll actually do that chapter 1 of this new book. Okay? All right. So in this first example, y equals 2x minus 1, notice it's already in slope-intercept form, y equals mx plus b. We never did talk about what x and y mean, and we sometimes ignore those, but what is x and y? What are those? They are letters, I agree. Yes, we call them variables even. All right, what else are they? Are x and y always the same? No, they are variables. They're going to vary. They are coordinates. They are coordinates. Now, we sometimes just ignore it, but it's important for you to note those are your coordinates. Those are your solutions, okay, to whatever line you have. So, for instance, if I put this line, y equals 2x minus 1, and I want an x and y coordinate that will be on this line, right? If we slope, or not slope, if we graph that line, we're down here. Where do we cross y? -1, that's the y-intercept, yes. That was not the resounding answer I wanted, but go with it. That is -1. What do we do from that point? Oh, talk to your group real quick. What do you do from this point? It's been a long time since algebra. You do not just draw a line through that point. There's an infinite number of lines. We've got to anchor that line with another point. How do we get the other point? Okay, volunteer now. How do we get the other point? Yes, Braden. You go up 2 over 1, also known as our slope. Rise 2, run 1. Rise 2, 1, 2, run 1. We're right there now. Rise 2 more. 1, 2, run 1 more. Okay? We now have a line. All right. There's my line. Now, x and y stand for coordinates on that line. So, for instance, if I say, well, We have 5. Darn. We're not going to do any software updates. Especially with this computer. Okay. Hey, if I have the point, the ordered pair 5, 1, which, just looking at the picture, does not lie on this line, that means this coordinate right here will not be an XY coordinate that will make this statement true. That's what XY means. And if you didn't know that, that means you made it all the way through 8th grade math and algebra, not understanding, truly understanding linear equations. And that's the coordinate. You may know what linear, y equals mx plus b. Woohoo! Okay, well, it means that you can plug a value in, an xy value, and it's going to make this true. Okay, and by the way, that goes for every line you graph. X and y are your coordinates. Okay, so as we go through this year and we study 13 different graphing patterns, and you memorize each of those, one of the constants is xy. Okay? All right, so we've got xy, 5, 1. If I put 5, 1 in here, let's just try it real quick. Make sure I'm not lying to you. Y equals 2x minus 1. I put 5 in, 2 times 5 minus 1. Okay, so this would be our 1 over here. Is that a true statement? We get 10 minus 1 equals 1, correct? No, it's false. Okay, now we just used rise and run to find that point. What is that coordinate? By the way, this means this one doesn't work. What's this coordinate? The ordered pair 2, 3. 2, 3. Okay. So 2, 3. If we plug that same one in, y equals 2x minus 1. Y equals, what's y? 3. What's x? 2 minus 1. How'd I get it? 2, 3 for those of you, that's x, y, remember? Okay, that's our coordinate. 2 times 2 is 4. 4 minus 1 is? True statement, yes? Meaning 2, 3 is a solution. Okay, that's what that is. So when someone says, hey, what does XY mean here? You can't just say letters. They're letters. They're variables. No, those are coordinates that lie on that line. Okay? All right, you guys talking over there. I'm going to have you come up and teach the rest of this. You be good? Okay, so, very good. We have this. It's in slope-intercept form. Notice example 2. Is this in slope-intercept form? No, tell your neighbor what you have to do. Put that in slope-intercept form. Okay, 2 things I heard just from this spot. I heard get y by itself, and I heard subtract 2x. Is that true? Yes, if I subtract 2x, that will get y by itself. Now, when I say subtract 2x, we mean subtract it from both sides. And Mr. Vogel and I both draw a line to separate the sides of the equation. So this gives me 0 there and a y left on this side. And over here, we'd have negative 2x plus 7. And notice that's what they have right here. So we're good to go. Okay, now they get more complex. Example 3 moves into this. They actually put a number in front of x. But notice here, we moved the x and got the y. I'm sorry, they put a number in front of y. So here we're going to move the x's again first. So first step, tell your neighbor. It is what? Subtract 3x. Now, I'm going to use their example. Now, they don't draw their line as straight as I draw my line. Okay? There's their line. That's okay. They've got 2 steps of the 2 parts of the equation. Notice they subtracted 3x and subtracted 3x. They rewrote it. Rather than 4 minus 3x, they did negative 3x plus 4. Tell your group why that would be. Why would they rewrite that to that? Okay, volunteer, why would I rewrite it like that? Quickly, this is supposed to be the easy stuff. This all review. Casey? Good. Up here, it's not in slope-intercept form. Here, you'd want the x's to come first. Now, to get rid of that negative 2, we add 2, correct? No, we divide by 2, and we divide everything by 2. We divide this by 2 and this by 2. We write it like that, and we end up going negative 2 and negative 3. Negative 3 divided by negative 2 is, negative divided by negative is positive 3/2 x, and then 4 divided by negative 2. Positive divided by negative is negative 2. So y equals 3/2 x minus 2. Okay, and then the last one, they make it a little more complex, maybe. Actually, I think this one's a little easier. But they add the 4x and then they divide by 2. Hopefully you could just look at this to transform it, and you could go, hey, or to change your equation, you could go, well, I'm just going to add 4x and then divide by 2. You know your 2 steps. Okay, we end up with 2x plus 4. Okay, so the first thing you have to do is to be able to graph linear equations and know what each part means. If you're there, that's good. You're on track. If you learned something there, right now, summarize what you learned on the bottom of the page. Write down what you didn't know. Like, at some point in here, you're like, I didn't know the answer to that question, but now I get it. And I remember. See, I remember. Like, I learned it 2 years ago. Now I remember. Okay? That means you didn't know it right before class. I could have come up to you outside and asked you the question. You had no idea, even though you knew it at one time. That's something you should write down on the bottom of the page. If you knew every single answer to every single question, you don't need to write down anything other than I'm cool. When I say I'm saying Mr. McCoy. Okay. Very good. Okay, I want you to read to your neighbor what you wrote. Okay, how many of you wrote I'm cool? Thank you. I appreciate it. On my desk? Thanks. Very good. Okay, hey, we're on the next page. Y-intercept and slope. Notice then they go into graphing these equations. Now, we already graphed it because we're cool like that. You even wrote it on the other page. I'm cool. Okay, so 2x minus 1, you graph this. You know the y-intercept is negative 1. You could rise 2, run 1, and then put another point. Repeat the rise and run to get a more accurate graph, and then draw a line. You should really do it more than once like they do.
Those points are very far away. You can easily have it not be very accurate.
Yeah. You should just keep doing that. Like, keep going up 2 and over 1.
Pretty cool. You just make one out.
And then you go the other way. Okay? So I'm not going to spend a lot of time there because we've already done that. So we're going to turn the page now. However, we are now looking at this one. Now, notice example 2, example 3, and example 4. Where did those come from? Yeah, I'm pretty sure there are these equations. Like example 4, this is page 1, 2x plus 4. Dude, 2x plus 4. All right. So they've graphed each of those for you. All right? What we're really concerned about, now that we know how to graph and we reviewed that, just one little note before I get to that. When this right here, and I've had a few algebra students now, or algebra 2 students, tell me they made it through algebra, rising 1.5 and running 1. Okay, that's good. I like to hear you say what to that because I don't like that. Okay? Like, they make this into like a compound fraction. Like that. Or they say it's 1.5 over 1 because 3/2. Now, that we frown on. Okay? We'll make that, and even stick our tongue out. Okay? That's bad. So this right here, we are rising 3. 1, 2, 3, and running 2. Rise, run. Okay? So if you've been taught, hey, let's make it a decimal and then put a 1 under it, let's not do that. Okay, very good. Transformations. This is really where we want to be. Okay, so let's flip back to the function. We have transformations. Please note they changed this rather than y equals mx plus b. It's kind of written in 2 different lines here, which is bad. Rather than calling it y equals mx plus b, they call it f of x equals mx plus b. Okay, so function notation replaces y with f of x. They mean the same thing. It's just one is called function notation. for those of you that recall function notation from algebra, f of x, this does not mean f times x. This is f of x. It means it's a function. It means y is a function of x. It depends on it. All right. So for any function, f of x, not just any linear function, these are going to hold true. Okay, there are 4 ways we can transform it. So here's where the meat of this is. And we're going to discuss just one of them right now. And then we'll kind of work our way into the others. You can transform it by adding to the input or adding to the output. Okay, that's how many ways right there? That's 2 ways. You can add to the input and add to the output. You can also multiply something by the input and multiply something by the output. Or multiply the output by something or the input by something. So you can add the input and output by something or something to it, and then you can multiply by something. Those are your 4 ways. Okay, so you have an input and output. That's one key term. Tell your neighbor what the input and output are on, actually, let's go to the function. Where's your input? Where's your output? Okay, volunteer, what's my input? Hey, no one seems to know, so just guess. Yes? I will say f of x is the output. The input is not y equals mx plus b, or mx plus b. Yes? X is your input. That's your input. Yes, if I was taking notes, I would write this down. Important stuff. That's your input. This right here is your output. X is the input, y is the output. Or f of x is the output. Okay, so the first thing we are going to do, this is going to be broken up into 4 different things. The first thing we're going to do is add to the output. Which one was the output? F of x. Okay? Now you'll notice Mr. Vogel and I, when we made this packet, we rewrote some stuff here. So in the function notation, when we're adding to the output, it looks like this. G of x equals f of x plus k. We are adding something, which we're calling k, to our output of f of x. And we're going to call it g of x. Why are we picking g of x? Because it's the next letter after f. We could have called it m of x. We could have called it v of x or Vogel of x. Okay, we could have called it whatever letter of x other than f of x, because we've already used f of x. Okay? Usually, you just use g of x next. Why? Because we're boring and not too creative. Okay? Good? So, g of x, so our new function, is going to equal our old function plus something. That's what adding to the output means. Seem difficult? Okay, thank you. I'm glad it doesn't seem difficult. Okay, notice k can be a negative, which would mean we're actually subtracting. So like if we add a negative number, it's like subtracting. That's why you don't see add and subtract up here, or multiply and divide. When you add a negative, you're actually subtracting. And when you multiply by a number between 1 and 0, you're actually dividing. Okay? Well, I guess negative 1 and 1. Okay. All right. So, in this notation, with this notation, what it means is we go ahead and calculate the value of the function, normal. We add k to it. So let's take a look at this. So we're going to take our first function, the one we graphed first. Well, f of x equals 2x minus 1. And we want to add 5 to it. So notice this got chopped off again. It went from here all the way over here. So we're going to rewrite it. Let's write it right here. F of x plus 5. And that's going to be equal to g of x. So we're going to take because we just picked 5. We could have picked any number. Actually, they picked 5. I didn't have anything to say about it. Like, this was already made. We could have picked 1 million, which would have made it a little more complex to graph. We could have picked negative 1 million, which would have been about the same complexity. We could have picked 1, but it doesn't show all that well in a picture. But 5 does pretty well, as we'll see. So it's just a random number we picked, or they picked. Make sense? Probably more explanation than you need. But, all right. So they added 5. All right? They meaning the math person in somewhere. Okay, g of x equals f of x plus 5. Notice all that's happened here, and if I were you, I would probably, let's take this, they kind of go through it really fast right here. Let's actually work through it so you know what's happening. So maybe take this function that is off the screen, take this function right here, and you have a bunch of white area right here. Let's go ahead and just write it here. That way we can work through it actually how we would do it on paper. You'll come to find out that this is the easiest of all the transformations. Okay? All right, so we're saying our new function g, which we stopped saying of x because we're lazy, so we just say g. G equals f plus 5. Okay? And f of x equals? Yeah, f of x equals 2x minus 1. How do we know? Well, it says it right here. F of x actually equals that. So using substitution, we can take 2x minus 1 and put it in for f of x. We're going to replace that part with 2x minus 1. I've been pretty brave so far. I've been using a pen, and I haven't made too many errors that have been caught. Hopefully none. But. Okay, so I'm going to start using my pencil now. F of x now becomes 2x minus 1. So I put it in parentheses. And I'm going to add 5 to that. Bring down that 5. And notice I'm not going to keep rewriting g of x because that wastes my time. Once again, I'm lazy and I don't want to keep writing that. Okay? So I'm just going to put the equal sign, meaning the g of x is just dropping down and following me. Okay? 2x minus 1 plus 5. Did the parentheses actually mathematically do anything? No, other than the one thing it does do is it shows us that you did substitution there, which becomes very important the further you go in math because you substitute more and more and more in problems. Okay, so every time you substitute, you should put parentheses, even if it isn't going to change anything mathematically. So here, 2x minus 1 plus 5, really mathematically it doesn't do anything, so I'll drop the parentheses for a minute. Usually I wouldn't show that step, but I'm going to. And that actually gives me 2x, what? Plus 4. So my new function, g, is 2x plus 4. Okay, how many are with me so far? Okay, any questions so far? Yes? Well, let me show that real quick, okay? So, right now, pictorially, we know that f of x equals 2x minus 1 looks like this right here. It's this graph. And over here, notice it says that's my original function. Over here, they've actually graphed that same graph here. That's your 2x minus 1. Okay, in terms of your equation, this is what happened. It's went from 2x minus 1 to become 2x plus 4. You've added 5 to your output, which gave us 2x plus 4. So when you actually graph it, and here's the key, you should know how these move on your graph. And so your question, do we put them on the same graph? Not all the time. It just depends what they ask. For this problem, we are doing them on the same graph. Okay, this is your 2x plus 4. So notice they said g of x is equal to f of x plus 5, which actually equals 2x plus 4. Okay, this graph is right there. Notice something about these lines. Well, first, they're parallel. Why would they be parallel? Yeah, they have the same slope. Slope didn't change. What did change was your y-intercept. In fact, the y-intercept of this one is at -1. The y-intercept of this one is at +4. How much did it change? 5. It changed 5. It translated 5 units up. Up what? The y-axis. Okay? So it's moved 5 units up. When we add to the output, we actually, and this is the way we write it, we translate, it's called a translation. In this case, 5, do they call it up 5 or 5 up in the book? Translation up 5. Now, Mr. Vogel and I add a word to it, just so that we can make this a lot easier for you. Our textbook doesn't always do this, but we add the word in front of it, vertical. This is a vertical translation, up 5. Because at some point, if we're defining it as vertical here, at some point, what type of translation are we going to do? Horizontal. This is a vertical translation. How do I know it's vertical? Because I'm adding it to the output. What is my output? F of x, or also known as y. And which one runs vertically? Y or x? Y. Okay? When you're adding to the output, which affects your y-axis, it's vertical. When you add to the input, which affects your x-axis, it becomes horizontal. We get to that next. This is a vertical translation up 5.
So last year from geometry, translation, what was that? Kind of a slang term for translation. Not a reflection.
Flips, turns, and slides. Sliding it up 5.
We slide things. Remember when we did stuff in geometry, we split things here and there. That's what this is doing. So the fancy name for it was translation, and that's what we're using here.
Okay, any questions there? Okay.